Most ocean plastic doesn't start in the sea. It begins on land, travels through rivers, and ends up polluting marine ecosystems. But how exactly does this plastic journey unfold? In this video, we uncover the hidden routes plastic takes from cities to shorelines. Don't forget to like this video, subscribe for more eye-opening insights, and discover how rivers are fueling a global crisis. 1. Plastic begins its journey on land. Most plastic waste starts inland, tossed away in cities, suburbs, and remote rural areas. Plastic packaging, bags, and bottles are often discarded carelessly in open environments. Rainfall carries this litter from streets, fields, and ditches into nearby water sources. Even in dry regions, strong winds can blow light plastic debris toward drainage systems. Storm drains funnel plastic into streams, canals, and sewer systems, often unchecked. Construction zones, marketplaces, and dumps are major contributors of scattered plastic. Landfills near waterways frequently leak waste, especially during heavy rainfall events. 2. Urban runoff carries plastic into streams. In cities, impervious surfaces like concrete prevent rainwater from absorbing into the ground. Instead, water flows over roads and rooftops, sweeping up trash and plastic as it moves. Stormwater systems were not built to filter out plastic or debris from these flows. When it rains, massive volumes of plastic litter are washed directly into drainage canals. These storm drains discharge untreated water into nearby rivers, lakes, or harbors. The faster and heavier the rain, the more plastic is picked up and flushed downstream. Urban flash floods often cause surges of garbage that overwhelm sewer infrastructure. 3. Rivers become plastic highways. Once plastic enters rivers, it begins a journey that may last weeks, months, or even years. River currents carry plastic downstream, sometimes traveling hundreds or thousands of miles. Large rivers like the Amazon, Yangtze, and Ganges act as global plastic superhighways. Floating plastic gets caught in whirlpools, branches, or riverbanks along the way. It breaks down under sunlight and friction, forming microplastics before reaching the sea. Plastic bottles, containers, and bags often stay afloat, drifting steadily toward estuaries. Heavy plastic sinks, scraping along the riverbed until it reaches slower-moving areas. 4. Plastic gets trapped in river obstacles. Along its journey, plastic encounters both natural and human-made barriers in rivers. Branches, vegetation, sandbanks, and debris piles can snag floating plastic momentarily. Dams, bridges, and boat docks trap larger waste like bottles and styrofoam blocks. These traps are temporary. Most plastic breaks loose with heavy rain or water surges. Some debris becomes microplastic while stuck, increasing river toxicity over time. In tropical rivers, mangrove roots catch large volumes of plastic waste in their networks. Trapped waste creates localized pollution hotspots that affect aquatic life and water quality. 5. Agriculture and industry worsen plastic flow. Agricultural plastic use has grown, with films, wrappers, and containers scattered in fields. During harvest or tilling, these plastics are often blown into nearby creeks and rivers. Greenhouses and irrigation lines also leak plastic fragments through wear and disposal. Fertilizer bags and pesticide bottles are discarded near canals in many farming regions. Industrial plastic pellets, known as nurdles, escape during shipping and manufacturing. These tiny pieces are easily swept into rivers through stormwater or factory drainage. Shipping ports and dockyards contribute massive plastic leakage during loading operations. 6. Flooding amplifies plastic movement. Heavy rainfall and flooding events wash tons of accumulated plastic into rivers at once. Floodwaters reach into garbage piles, landfills, and streets, pulling waste into the flow. As rivers swell beyond their banks, plastic from adjacent areas is swept into the water. Entire dump sites have been submerged and emptied by floodwaters in coastal countries. Flash floods pick up plastics hidden under soil, vegetation, and street infrastructure. Once the flood recedes, the plastic continues floating downstream at accelerated speeds. Flood-driven surges can overwhelm cleanup efforts or barriers placed along riverbanks. Plastic carried during floods spreads across wider areas, reaching deeper into river zones. 7. Estuaries are the final gateway. Estuaries, where fresh water meets salt water, act as the final checkpoint for plastic waste. They are biologically rich zones, but are increasingly clogged with plastic pollution. Plastic accumulates here in massive quantities, forming dense mats and submerged fields. Tidal movement pushes plastic in and out, trapping it in estuary mud and mangroves. Some debris washes back upstream briefly before getting dragged out again at low tide. Estuary ecosystems suffer immensely from this plastic congestion, choking marine life. Birds, crabs, and fish become entangled or ingest plastic waste in these transitional zones. Once plastic escapes the estuary, it is essentially lost to the open ocean indefinitely. 8. Ocean currents carry plastic across continents. Once plastic exits rivers and crosses estuaries, ocean currents take control of its journey. These currents form massive circular patterns known as gyres, trapping floating plastic. The Great Pacific Garbage Patch is one example of how currents concentrate ocean debris. Plastic can travel from one continent to another within a year by riding current systems. Waste from Asia has been found on American coasts, European debris on Arctic shores. Ocean currents sort plastic by size and density, scattering microplastics globally. Some plastic washes back onto coastlines, but most stays at sea for decades or longer. Currents also pull floating debris into coral reefs, harming marine biodiversity severely. 9. Human health risks begin in rivers. Plastic flowing through rivers does not only threaten fish and oceans, it also affects humans. Microplastics in rivers enter drinking water systems through poorly filtered supplies. Communities using river water for bathing or cooking are exposed to toxic contaminants. Plastic particles absorb harmful chemicals, which then enter food chains through fish. River fish caught for food may contain plastic in their tissues or digestive tracts. Ingested plastic disrupts hormones and may contribute to long-term health issues in people. Livestock that drink contaminated water may pass plastic residues to humans via milk or meat. Rural populations depending on untreated river water face the highest exposure risks. 10. The solution lies upstream. By the time plastic reaches the ocean, it is nearly impossible to remove or recover efficiently. The most effective solutions begin upstream where the waste first enters the environment. Better waste management, education, and infrastructure reduce leakage into rivers. River barriers and smart booms can intercept floating plastic before it flows out. Governments must invest in collection systems and enforce anti-dumping laws aggressively. Community cleanups, local bans, and corporate responsibility all play key roles upstream. Technology must be paired with behavior change to prevent plastic from entering waterways. Monitoring river plastic loads helps identify key hotspots and develop targeted interventions. Rivers are the plastic highways no one talks about yet. They're key to stopping ocean pollution. By tackling waste upstream, we can make a massive difference downstream. Don't forget to like this video if you learned something new, subscribe for more powerful environmental stories, and share this to raise awareness about how everyday trash becomes an ocean disaster.